Hello guys, today we're going to continue on with part 1, Ratios and Fractions of Chapter 4. In the last couple of lessons we've talked about ratios, what are ratios, and then we spoke about equivalent ratios. So today we're going to talk about fractions and equivalent fractions. So I'll give you a second there to write down the section title here, the lesson title. So pause the video, and when we're ready, we'll move on. Okay, so a quick little review. We talked about the example that 1 to 2, this ratio, so 1 blue block to 2 red blocks, is equivalent to 5 to 10. So they show the same comparison, they're just written a little bit differently. Okay, so if we have 5 blue blocks, we would have 10 red blocks, which is what we see here. So the comparison of both is still the same. It's still the same ratio. It's just written a little differently. And how do we get this? We times our 1 by 5 and our 2 by 5 to get 10 here. Okay, so quickly from last day, I want you to tell me now, give me 2 equivalent ratios for green to blue triangles. So just pause the video, think about that, and when you're ready, come back and I'll give some examples. Okay, so by now you should have tried this one in your mind or written it down in your exercise book. No need to draw out the blocks, just I want to see the ratios. So what we have here, one ratio I would say would be 2 green blocks. The 2 green blocks to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 to 12 blue blocks. Okay, another equivalent ratio is that I could just look at half of this and look at this ratio here, represents still the same green to blue, but it's just written a little differently. Here we have 1 green block to 6 blue blocks, and they're equivalent, so we can write that as equal. Alright, so all I did was divide both my 2 and my 12 to 2 and 12 by 2. So divide 2 by 2 as 1, and divide 12 by 2, and you get 6. Okay, so that's divide by 2. I can also times what I have by 2 and get another equivalent ratio with bigger numbers. So I'm going to do that now. I'm going to times my 2 by 2 to get 4. So it would be 4 green blocks. And if I have 4 green blocks, how many blue blocks would I need to keep the ratio the same? I would need to multiply this by 2. So 12 by 2 is 24. So this is another equivalent ratio. It's written a little bit differently, but it still represents the same amount, the same ratio or comparison of green to blue. Okay, you guys might have got some different answers here. That's okay if you wanted to give different equivalent ones. There are lots and lots of equivalent ratios to these. These are just the ones I thought of first. Okay, so with that being said, I'll have a little tiny note for you to write down. I just want you to write down what's in the yellow block here. Okay, so pause the video, and when we come back, we'll talk about this, and then we'll move on. Okay, so just a little communication tip for when you're using the language of math, I'll say. You can use the equal sign to show that 2 ratios are equivalent. So for example, we talked about how 1 to 2 is the same as 5 to 10. So we can use that equal sign to show that they're equivalent, that they're the same. Okay, ratios and fractions. So now we're going to ask, what is a fraction? Now, you may have used fractions before and seen fractions and talked about fractions before, but we're just going to look at it from a visual perspective, looking at some examples where you can really see what a fraction is. So what is a fraction? Fractions are very similar to ratios, what we talked about already. They're just written and represented a little bit differently. So for example, we're used to seeing something like this. We talked about ratios. If I ask for the ratio of shaded blocks to all blocks here, so part to whole ratio, I would have 1 shaded block to 4. And we represent 2 by the colon, remember? Okay, now a fraction, we don't have little separate pieces. Instead we have one big piece that's divided into smaller pieces. So a fraction, I would ask, okay, tell me the fraction of shaded blocks out of everything, or just the fraction of shaded blocks. I could say it like that. So here we have 1 shaded block out of 4 parts. Okay, so 1 out of, and this is how we say out of in math, 1 out of 4. So this is a ratio, 1 over 4. Okay, so I want you to pause the video, and I want you to write down this note right here, and I want you to quickly draw out some diagrams to go with that. Okay, by now you should have this note written down. Now, you don't need to write this down, I just want your attention here. So what fraction of each shape is shaded? Alright, so I'm going to quickly do these. So for A, what do we have? We have 1 shaded out of how many parts or pieces did we have? 1, 2, 3, 4, 5, 6. So A would be 1 over 6. That's the fraction of shaded pieces here. What about for B? We have 1 piece shaded out of 2 equal pieces. C, we have 1 shaded out of 1, 2, 3, 4, 5. And D, can you do that one in your head? What would you get there? Okay, so it's 1 shaded out of, and then we have 12 pieces altogether. So we're just using math and numbers to represent these shaded parts, these representations, okay, these visuals. Alright, so here's some words that you need to know when you're dealing with fractions. First off, here we would have 3 shaded. 3 shaded out of how many? 1, 2, 3, 4, 5, 6, 7, 8. So we have 3 out of 8. So the number on top of the fraction is called the numerator. What we say here, the 3 out of 8 shaded, the out of is the fraction line. Okay? And our denominator is the whole. How many pieces do we have all together? So 3 out of 8. So the numerator is on top and the denominator is on the bottom. Okay, numerator on top, denominator on the bottom. Alright, when you get a chance, I want you to pause the video and I want you to write down what's right here in the red box. Okay, by now you should have that written down, and just to again compare to ratios, here we have a very similar looking visual, except our pieces are separated. If I asked you to compare shaded blue blocks to white blocks, or shaded to all, sorry, so we're comparing our blue blocks to all blocks, I would say we have a ratio of 3 blocks to all, 1, 2, 3, 4, 5, 6, 7, 8. So we can see how that's similar. Fractions and ratios, we can see how they're similar. It's written a little bit differently. Okay, so I've designed the flag using a 6x4 grid. That just means I have 24 pieces. And I've used the colors yellow, blue, and red. So we have 24 pieces in whole. I want you to tell me the fraction of blocks that I have shaded yellow. the fraction of blocks I've shaded yellow out of the total. So I have 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 yellow blocks out of 24 blocks total. Okay, blue, I have 1, 2, 3, 4 out of how many total? 4 out of 24. And red, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 12 out of 24 shaded. So you have a task now. You're going to pause the video and you're going to create your own flag using just 3 colors. And then you're going to write down the fraction that is shaded for each color. So similar to like what we've done here. So you can pause the video. That's going to take a little while. And when you're ready, come on back and we'll continue on. Okay, so by now you should have your flag complete. And we're ready to move on to talk more so about equivalent fractions. Alright, so now I want you to compare these. So I asked you how much is shaded out of all these. Okay, so how much is shaded here? I have 2 pieces shaded out of 2. Here I have 3 pieces shaded out of 3. 4 pieces shaded out of 4. And here I have 6 pieces shaded out of 6. So which one has more shaded? Well, that's a trick question because all of them are fully shaded. Everything is shaded here. They're all the same size. If we look at it like this, if I take this whole circle and place it over the blue circle, they're the same size. Okay, same size and same size. So we see, it's a trick question. None of them are bigger. They're all actually the same. So these are actually all equivalent fractions. So we can say that these are all equal. Even though they're divided into different pieces, at the end of the day, they have the same area shaded. Okay, so keeping that in mind, no need to write that down. Okay, so what do the fractions in example 1 here have in common? Okay, so we're going to answer this question now in a second. First off, I want you to write down the fraction that represents the shaded part of these pies or circles. So here I have 1 piece shaded out of 2, so 1 over 2. Here we have 2 pieces shaded out of 4, 2 over 4. This is 3 out of 6 pieces shaded, and this is 4 out of 8 pieces shaded. So now we come back to this. What do these fractions have in common? We see they all represent the same shaded area. They all have the bottom half shaded. So even though they're written a little bit differently and divided into more pieces, we can see at the end of the day is the same amount shaded in all of these circles. Okay, so no need to write that down, just think about that. Alright, so here's where we make the connection to math. So we're going to take the fraction of half, and we're going to multiply the numerator. Remember, that's the top number by 2. So I'm going to write that in red ink. And we're going to multiply the denominator by 2. So 1 by 2 is 2, and we're going to make a new fraction now. And 2 by 2 is 4. So what do we see here? We multiplied our top and our bottom both by the same number by 2, and we got 2 over 4. And when we look, 2 over 4 is this special fraction that has the same amount shaded as 1 over 2. Okay, check this one out. Alright, we have 1 over 2, and I want you to multiply the numerator and the denominator by 3. So the top by 3, our numerator, and our bottom by 3. So 1 times 3 is 3. 2 times 3 is 6. So we're going to write a new fraction. And when we look, that's one of our, what we call equivalent fractions. Okay, the same amount of the circle is shaded, it's just written a little bit differently. So we see this equals that. It's just written a little bit differently. One last go. 1 over 2. Multiply the numerator by 4 and the denominator by 4. And we get 4 over 8. And we see that yes, they are indeed equal because they have the same amount shaded. They're just written a little bit differently. They're divided into more pieces or less pieces. It doesn't matter, but they still have the same amount shaded. So make the connection now. We can see that all these fractions here are equal. They just look, they're just represent, they're just written and shown a little bit differently. So here's an important note. I want you to write this down. If you multiply the numerator and the denominator of a fraction, so if you multiply the top and the bottom by the same number, the answer will be an equivalent fraction. So what we call an equal fraction. It will be the same thing shaded all together, but it might just be divided up a little bit differently. So write that note in your book. So if you multiply the top and the bottom by the same thing, the answer will be equal. Okay, pause the video. When you're ready, come on back. Okay, so we're almost done for today. Now, with the information we just learned, timesing our top and our bottom by the same number will give us an equivalent fraction. I want you to write down in your exercise book 4 over 5. And then I want you to write 3 equivalent fractions to that. Try it on your own. When you come on back, you compare it to my answers. If you're unsure what to do, just follow along with me. So pause the video here if you want to try it on your own. If you're ready to do that, I suggest doing that, giving it a go. If not, wait for me. I'm going to start now in a second. Okay, so 4 over 5. If I want to make an equivalent fraction, so remember, equal, equivalent, same thing, equivalent. So I wrote down my equal sign. Okay, I could make it into anything, any equivalent fraction I want, as long as I multiply the top and the bottom by the same number. So I'm going to multiply my top by 2. So if I multiply my top by 2, I have to multiply my bottom by 2. So 4 times 2 is 8. And 5 times 2 is 10. Okay, so that's one equivalent fraction. If we were to draw this out, they would, even though the pie would be divided up into different amount of pieces, it would still have the same pieces shaded, same amount. Okay, so I'm going to do another one now. 4 over 5. I'm going to multiply top and the bottom by 3. So 4 times 3 is 12. And 5 times 3 is 15. So this is another equivalent fraction. So I can do another one. Multiply my top by 5. I'll multiply my top by 5. 4 times 5 is 20. My bottom by 5 is 25. And one last one, I'm going to do an extra one for good measure. I can multiply my top and my bottom by 100. So 4 times 100 is 400. 5 times 100 is 500. So all of these, all of these fractions are equivalent. They're written a bit differently, but it is the same amount shaded of a pie, if we had a pie here. It's the same amount shaded. Okay, so your answers might be similar to mine or a little bit different. Just double check them. The main thing is you multiply your top and your bottom by the same number to get an equivalent fraction. Okay, so if I have 4 over 5, what's an equivalent fraction to that if you have a 10 denominator? Well, how did I go from 5 to 10? I multiplied by 2. So for it to be equivalent or equal, shown by this sign here, we need to multiply our top by the same thing. So 4 times 2 is 8. Okay, so these fractions are equivalent. Try this one here. Here I multiplied by 3. So what do we got to do to the top to make these fractions equal? I have to multiply 2 by 3. So 2 by 3 is 6. Okay, and last one. How did I change the bottom here? Multiplied by 2. So I have to multiply this by 2. It's going to be 6 over 12. Okay, so the last thing for today, I want you to copy this out in your exercise book. And I want you to write, I want you to fill in the blanks, okay? Find the equivalent fractions here. And that is your practice work for today, just to complete these. So make sure you copy them out in your exercise book and then give them a go. So I hope you enjoyed this lesson. Let me know if you have any questions about equivalent fractions. And good luck with these practice examples.